Most of the time when you see transformations, you are not going to have just a single transformation to do. You're going to have several together. Okay, so when you're doing multiple transformations, the order that you do them in can affect the outcome. So it does matter. So we're going to summarize that information here. So first of all, horizontal versus vertical, the order does not matter. They are independent of each other. So you could do all the horizontals and then the vertical, or vice versa. You could do one of the horizontal, then the vertical, then the horizontal. That doesn't matter because they're independent of each other. But when you're talking about horizontal transformations, the order does matter. Remember how we are trying to solve for x or undo what happened to x. So we are always going to have to do our shifting first. So shift left or right. And then we're going to do our stretching, shrinking, or reflecting. The order on those doesn't matter because they are all part of being multiplied in the equation. So stretch, shrink, reflect can be done together in any order. But it's just that you have to shift it first and then do the stretching, shrinking, and reflecting. In the vertical, that's reversed. So in the vertical, you're going to start by multiplying or dividing. So in other words, stretch, shrink, reflect comes first. And then second, we're going to shift up or down. Okay. The way that I remember this, it's not random. It really isn't. In the vertical, you're doing this to the whole function. So you want to follow the regular order of operations. I'm thinking most of you have heard of PEMDAS before, or please excuse my dear Aunt Sally. But what that stands for is the order of operations that we do things in. So parentheses, exponents, multiplying and dividing. That's what these are. Number one. Okay, stretch, shrink, and reflect are multiplying and dividing, and then adding and subtracting. And the adding and subtracting is where you're shifting up and down. So it's just regular order of operations. You're multiplying and dividing, then you're adding or subtracting. When you're doing the horizontal transformations, you are solving for x. So SADMEP, maybe you never heard of SADMEP before, but that's the reverse order of operations, right? So we need to shift first. We need to do our adding and subtracting first. Then we'll do our multiplying and dividing second to be able to solve for x. So it's just reverse order of operations. Let's see this in action, and I think it will make more sense. I'll show you how I think of it, how I solve for x. Whee! Let's see. Let's try this again. Okay, inch, 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 inch. So as you can see on these first two problems, these are the ones we're going to do together, there are several transformations happening. And so we're going to write each one down and what it does. Okay, so we have 3 absolute value of x minus 4, and then outside of that we have minus 2. Okay, so I want you to notice that we have inside this absolute value is x minus 4. That is the horizontal part. Okay, everything outside the absolute value is the vertical part. So only the minus 4 is what's happening horizontally. Okay, so what I like to do is write down what transformations I have. So I would write, what are my vertical transformations, right? So I have this 3. So the first thing I see is 1. I want to multiply by 3, which when I multiply by 3, that is a vertical stretch by 3, right? We did that one on the front where we had 3 times the function. Okay, the second thing that I have in the vertical direction is minus 2. Okay, that's that shift down. So that is a vertical shift down 2. Okay, so those are the two things that I am doing in the vertical direction. And I did do very similar ones on the on the first video if you're not sure where I got what my choices there. All right, these are both happening to the y value. So I want to write the y value and write what's happening. So in other words, 3 times the y value for the vertical stretch and then minus 2. Okay, so for every y value on the original equation, I'm going to do 3y minus 2. For the horizontal, like I said, I put that in the highlighter there, x minus 4. That is just one shift, right? And when you're adding and subtracting, you're shifting. And remember, we want to add 4. So that is a horizontal shift right 4. Okay, so in other words, in the x, I'm going to take every x coordinate and add 4. Okay, I'm undoing what happened to x. That's why it's the opposite. Okay, so my original function is not a parabola this time. I don't know if you noticed that. It's the absolute value. Okay, remember that looks like the v. So we want to get with our table, we need our values from our original. So this is just y equals the absolute value of x. And then this is our new function. I can't fit it there. Okay, so our original values for absolute value would have been actually the same, -1, 1. When you put in 0, you get 0. When you put in 1, you get 1. It's just that they're straight lines instead of curves like a parabola, right? All right, now when we do our transformations, we're going to do 3y minus 2 for the y's, and we're going to do x plus 4 for the x's. So let's do that all at once, I think. So for the x's, x plus 4. So -1 plus 4 gives us 3. 0 plus 4 gives us 4, and 1 plus 4 gives us 5. So I color-coded this a little bit for you. So the horizontal, what I'm doing is right here. For the vertical, I did this in purple, 3y minus 2. So I want to take the y value of 1, and I want to say 3 times 1 minus 2. So that's 1. And then my y value for the second point is 0. So 3 times 0 minus 2, so that's -2. And then I'm putting in 1 for the y value, and that's 3 times 1 minus 2, which is 1 again. Okay, so these are the points that I'm going to plot now. 3, 1, 4, -2, and 5, 1. I'll just plot it in purple, I guess. Okay, so 3, 1, 4, -2, and 5, 1. Okay, and then remember it's an absolute value, so it's made up of 2 straight lines that make it look like a V. It should still look like a V, it's just a different shape than the original V. Okay, let's do one more together in this video. So first we're going to write down what's going on in each direction, right? I'm also going to highlight here. Notice that all this stuff is inside the absolute value. So this is what's happening in the x direction, okay? So I think this time, I might write what happens in the x direction first. So to the horizontal, right, I have 2 things going on. So the first thing that I have to take care of, it's 1/3 x plus 2. So I need to shift the 2 first. I need to subtract 2 first. So this is a shift. Let's see, since I'm subtracting 2, that's left. Shift left 2. Okay. And then it's 1/3 x. So I need to multiply by 3 to undo what's happening to x. Okay, so that would be a horizontal stretch by 3. Okay, again, undo what's happening to x. So imagine if this was like a little equation, 1/3 x plus 2 equals potato. Okay, the first thing you would do to solve for x would be subtract 2. that's the shift. Then you wouldn't divide by a third, you would just multiply both sides by 3. That's what's happening here, okay? So in other words, we need to take the x, right? And we're going to add 2, okay? And then we're going to multiply that by 3. I'm going to put that in parentheses just to show, like, I want to add the 2 first. Oh, sorry, and it says shift left. So, and remember I said left, I would want to subtract 2. Remember, I'm doing the opposite. So I have to subtract 2 and then multiply by 3. I'm purposely like leaving these little mistakes in there to like keep you thinking. I'm not saying I'm making them on purpose. Just not, I wouldn't say that. But you know, if I can catch them easily, I don't want to confuse you in any way, but I think it's better if you see the, you know, that it's not perfect the first time and it's a work in progress, and you know, that's how you learn. So that's why I am leaving those. Okay, so in the vertical direction, all we have is -1, right? And that is the shift down 1. So that is shift down 1. And how we write that would be the y -1. The verticals are always a little easier than the horizontals. Okay, so now we need to make a little chart for this. And I think I'm going to fit the chart right here in the middle. And I'm going to use the same colors that I used here. So I have the light green for horizontal. Oh, first I have to write my original. Again, it's absolute value of x. And then I'm going to use this function for the change. So my original points, same as above. Okay. And then my new points, let's use the new light green. So for the x's, I'm going to subtract 2. So -1 minus 2 is -3. Multiply by 3, that makes it 9, -9. Let me double check that. So -1 minus 2 is -3 times a 3, yeah, is equal to -9. Then 0. 0. So 0 minus 2 is -2 times 3, that's -6. And then 1 minus 2 is -1 times -3, so that is -3. All right, and then for the y's, all I have to do is subtract 1 from each y value. So 1 minus 1, oh, let's get that other darker green color for the y's. 1 minus 1 being 0, 0 minus 1, -1, 1 minus 1, 0 again. Okay, let's plot this and see how it turns out. So -9, 0, -6, -1. So right there. And then -3, 0 right there. Okay, so here's the bottom of our V. Goes this way. There we go. Okay, so it is, you know, a stretched out V and it's shifted over. And you might think that it would shift, you know, only the 2, but it's actually shifting 2 times the 3, right? That 1/3 is also affecting it because of the order of operations. So this is how it would look. And then of course, shift down 1 is simple.